Okay, so here we have the system of equations, and we want to solve it by substitution. Now, you'll notice that both of these have been solved for y in terms of x. This one says that y is equal to negative 2x plus 6, and the other one says that, whoops, hold on a second. The other one says that y equals 3x minus 12. So how can y be equal to do two different things? Well, y is what y is. And so the cool thing about this is that if this is equal to y, and this is also equal to y, two things that are equal to the same thing are equal to each other. So let me show you what I mean. Negative 2x plus 6 equals y, right? But it also says that y is equal to 3x minus 12. So if I erase this y, and I can put in 3x minus 12. So those two things are equal to each other. Now, you've been taught how to solve equations that have variables on both sides in your past this year. As a matter of fact, I know that I taught it to you. Um, so let's take a look at that. We need to get all the variables from one side to the other. So we're going to work on getting, I'm going to add 2x to both sides, because if I do that, then I don't have any variables or their coefficients on this side. They all move to the other side. And so I end up with 6 equals 3x plus 2x is 5x minus 12. All right. Now, of course, I need to get my constants to the other side. So I'm going to add 12 to both sides. Those cancel each other out. And 6 plus 12 is 18. And that is 5x. Okay. Now I've kind of run out of space. So I'm going to move from here and start again up here. 18 equals 5x. Hopefully you don't write nearly as big in your book as I do on the computer screen. Now I need to divide both sides by 5, because when I do that, I get x by itself and 18 over 5. Okay, and that's basically what it comes down to, 18/5. Or I could, if I wanted to make it a decimal, I could say, well, that's 3.6. That would be okay too. 3.6 equals x. Okay, now I know what x is. Now that I know what x is, I can take that value and I can put it in for x in any one of these other two equations. So let me put it into this one right here, where that x is. So that was y, because now I have to figure out what y is. Y equals 3 times x, which x is 3.6, minus 12. Okay, what is 3.6 minus 12? 3 times 3.6 times 3. 10.8. Okay, so y equals 10.8 minus 12. And 10.8 minus 12 happens to be negative 1.2. All right, well, we found our x, and now we found what y is. So to answer our question, I'll put this clear over here in purple, clear over here to the right. The solution to our equation is 3.6 comma negative 1.2. That's the solution. We solved it by substitution. Used my calculator a little bit. Now, if you wanted to have your answer in fractions, you could have done that as well. Either way, it's entirely up to you. All right. Now, question 5 says, when might you use substitution method for solving systems? Well, there are a couple of things you should look for. If you're going to decide, we're like, gosh, will I use substitution? Well, here's when you'll use substitution. You'll use substitution when you can see something where it says like y equals something, because it's easy to substitute whatever you find here for y in one of those equations. Or, or if you see, x equals something, because then it's easy to substitute those things into the other equation with very little trouble. The other instance when you might want to use substitution is when it's easy to solve for one variable or the other. Like perhaps you might see something like, if you've got an x plus a y equals something, because then you can go, oh, well, all I have to do is subtract x from both sides, subtract x from this side, and then y equals whatever minus x. So I guess what I'm saying is you would want to use substitution when you're either given the value of y or x, or if it's easy to solve for one variable or the other. So if it's super easy to solve for one of those variables, then you're like, yeah, I could use substitution for this. Piece of cake, no problem. Otherwise, it's too much work. All right, so moving on, let's take a look at question number 6. At the beginning of exploring, you considered the following system. This is a long time ago. Now we're going to solve it using substitution. So you can see now which of these equations will we use to start with. You're probably looking at it. Hopefully you're looking at it and going, well, Mr. Eaton, I am going to guess that this is the equation that I would solve first, because you can see right here, I've got that single y. And so I can solve this equation for y really quite simply. So I'm going to go over here and do this. 4x plus y equals 1. Now watch how easy it is to solve for y. I'm going to subtract 4x from both sides. And when I do that, these two cancel each other out, and it just becomes y equals 1 minus 4x. So now I know what y is in terms of x. So I can use this anytime I see y in the other equation. I can just say 1 minus 4x and substitute it. So now all I have to do is go, all right, well, that's 6x plus 3 times 1 minus 4x equals 2. And then we simplify this equation. First of all, take my 6x and bring it down, because I don't have to do anything with that, but I have to distribute my 3. 3 times 1 is 3. And then I have to distribute it to the negative 4x. Remember, that minus sign that's in front of that goes with that everywhere it goes. 3 times negative 4x is negative 12x equals 2. Just bring the 2 down. Now I can combine my like terms. 6x, negative 12x. 6x combined with negative 12x will give me negative 6x. And then I'm going to bring my positive 3 down and my 2 on the other side of the equal sign. Now I'm going to have to subtract 3 from both sides. Now I'm just continuing to simplify this thing. Those cancel each other out, and I get negative 6x equals 2 minus 3. Well, that's negative 1. Next step would be to divide both sides by negative 6, following my algebra rules. And I get x equals negative 1 divided by negative 6 is 1/6. And I'm going to leave that as a fraction, because I know that's going to be a repeating decimal if I do anything else with it. But I have solved for x. Now all you have to do is go back to the equation that we built up here, right? This one here. And we can substitute x in, the value of x for x. So this becomes y equals 1 minus 1/6. Whoops, hold on a second. My bad. Wrote it wrong. Y equals 1 minus 4 times 1/6, because that's what x is. Okay, now we just do what we know how to do. 1 minus, now what is 4 times 1/6? Well, that's 4 over 1. 4 times 1 is 4. 1 times 6 is 6. Let's see, how about so 1 minus 4/6. You know what? 1 is 6 over 6. I'm just going to make this easy on myself. 1 is the same thing as 6/6, correct? So 6/6 minus 4/6 equals 2/6. But I can simplify that. So y is 1/3, because I divided both of these by 2, which gives me 1/3. So y equals 1/3. See, now I have solved for x. I have solved for y. And so the answer to the question is x is 1/6 and y is 1/3. Dun, dun, dun. And you can go back and check by substituting both of those into both equations, and you're good. You're done. All right. Now, before we go, hold on a second here. Let me, that's not what I want. Hold on. I'm going to give you the link to this, to the forms for this assignment in the chat, so that you can get started on it before I am actually able to put the assignment into Teams, because I haven't gotten to that point yet. I don't believe. Nope, because I still need to record the video. Let me stop my recording.